Now let's go ahead and talk more about experimental design and do a couple examples. So, statistical studies or experiments are done to see if a treatment has an effect on the outcome. And this outcome is actually called the response. So, when you're first reading a statistical study, oftentimes the first thing you want to do is go ahead and decide what is the treatment and what is the response, and then go into evaluating the study. So, we're going to consider studies based on the point of view of the researcher designing them. And if the researcher decides who goes into each group, then the investigation is called an experiment. So there are two groups in all experiments, and they are called the treatment group and the control group. So the researchers are going to decide who gets the treatment, those people go in the treatment group, and then who doesn't, those people go in the control group. So this group one, I was calling the treatment group. This is just a group of people who get the treatment. So this is the group that gets the treatment. And then group two, we always want to have a comparison group so we can actually tell if group one did better or worse or stayed the same. We need something to compare it to. And that is called the control group. And that word control, you can think of it as this is a comparison group that we collect data on. So I'm going to say it's a comparison group that does not get the treatment that we collect data on. So, in contrast to the controlled experiment, if the researcher just studies the effects of the treatment but actually plays no part in choosing who gets it, then we're going to call this an observational study. And observational studies are not ideal. They're done out of necessity. So, whenever possible, we want to do a controlled experiment. So, when researchers are designing experiments, their goal is to make the treatment and control groups as alike as possible. Because if they're as alike as possible at the beginning of the study, then at the end of the study, if they're different, we know that that has to be because of the treatment. And there are a bunch of different ways that researchers can divide subjects into a treatment and control group, but randomization is best. So, randomly dividing the subjects is kind of the ideal experimental design because it's the design that's most likely to make the two groups as alike as possible. Basically, this is because it eliminates any human bias. If we're doing this randomly, there should be no human bias involved. And with enough subjects, any random differences are going to average out. And these are not only differences that the researchers identify as important, but also differences that the researcher might not even realize exist or are important. So, this kind of brings us to our ideal experimental design. If we could design the perfect experiment, here are the characteristics of what it would contain. So, we call this the randomized controlled double blind experiment, or sometimes you'll see them called RCTs, which stands for randomized controlled trial, especially in medicine. That's a terminology that they like to use. But like I said, this is the best. This is the gold standard of experimental design. And there's three parts to it. So the first part is the randomize. And we talked about that. We said we want to randomly divide the subjects into the two groups because it eliminates human bias. So the design should be randomized. The second part is actually the controlled. So we want to have that control group or the comparison group. So the second thing for the ideal experimental design is that it must be controlled. We want to have an explicit comparison group that we collect data on. And sometimes, if you don't have a control group, you might see more positive outcomes than what really exists because you don't have that baseline comparison to make. And then the third thing, the third part of the randomized controlled double blind experiment is the double blind. So, double blind basically means that both the subjects in the study and the researchers evaluating them don't know who's in the treatment and control group. So, now let's go ahead and talk about why that double blind specifically is so important. There's a couple different reasons. So the first one is because whether or not people think they've been given a treatment actually can affect their response. And we want to be able to separate the effects of the actual treatment from the idea of a treatment. And so to do this, the subject should be essentially, we call it blind to this knowledge. And you've probably heard of something called the placebo effect. So oftentimes the control group, instead of getting no treatment, will get a fake treatment called a placebo. And the placebo makes it easy to have the subjects be blind and not know which group they're in. And both of the groups then, if the control group gets a placebo, both of the groups then know or don't know whether or not they've been given the treatment. And so the responses can be attributed to the treatment itself and not the idea of the treatment. So the placebo effect basically says that sometimes when people get a fake treatment, they might psychologically think that they're doing better, but really they're not actually. So that's the first part of the double blind, is that the subject shouldn't know which group they're in. The second part is that the evaluators shouldn't know which group they're in. And this is because knowing which subjects received the treatment and which didn't could potentially bias the people that are evaluating the results. Like maybe the people, if you're testing a drug and the people that got the treatment were being evaluated and the evaluators thought that that treatment should work, maybe they won't give them as good of care as the people that didn't, or something like that. So to eliminate this type of bias, the evaluators should also be blind to this knowledge. So that's the idea of double blind, and that is key in many of these studies. Randomized controlled double blind experiments are becoming more and more common, especially in the medical field, economics. Everybody knows that this is the gold standard. So now that we know that, let's actually look at an example. And the first example we have is about, it looks like the treatment is something called ginkgo biloba. So I'm going to go ahead and read what it says, and then we're going to think about what we know about experimental design to answer the questions. So this says that a study was done to test whether ginkgo biloba, which they're abbreviated as GB, could alleviate the symptoms of Alzheimer's and dementia. This was a 52-week study, and there were 500 participants, all with Alzheimer's and dementia. And then it says half were, I like this, randomly assigned to either take the GB daily or take a sugar pill daily. So that's implying there is a placebo. So a placebo can be a sugar pill, it can be a shot of water, it can even be something like a fake surgery. And then if I keep going, it says neither the subjects nor the evaluators knew who was in each group. So that is essentially telling us this was a double blind study. So right away, just by reading that first part, I know that this was our ideal experimental design, right? This was the randomized controlled double blind experiment. And so the nice thing about these randomized controlled double blind experiments is that we can tell if our treatment worked or not. That's why we like them. So whatever conclusion they come up with, I can trust because this study was designed really, really well. And the very last sentence, it says at the end of the study, there was significant evidence that the GB improved cognitive performance and social functioning of the patients for 6 months to 1 year. So because we did our ideal experimental design, I can say this seems like it worked, which is a really powerful thing. So answering these questions, this is kind of just getting us used to reading studies and picking out the important pieces of information. The first part says, who are the subjects? So the subjects are just the people in the study. So in this case, I'm going to say they were the 500 participants, with, and it said that they all had either Alzheimer's or dementia. So those are my subjects. And then it does ask what's the treatment and what's the response. So the treatment, again, is the GB, the pill that they're taking. And then the response is essentially the outcome. So it told us that the response was that they had improved cognitive performance. Improved cognitive performance and social functioning. So always a good idea to start with figuring out, okay, what is this study about? What's the treatment and what's the response? And then the second question asks us, was there a control group? Did we have that comparison group? And if so, who was in it? And here it did say that half the subjects were randomly assigned to take the GB, so that's our treatment group, and then half were assigned to take the sugar pill daily. So I'm going to say, yes, there was a control group. And this was who was in it. I'm going to say half the patients, and they got the sugar pill. So the next question says, was there a placebo? And yes, we said there definitely was, and that was the sugar pill. And then D said, was this experiment double blind? And it did say neither the subjects nor the evaluators knew who was in each group. So that is an indicator that this was double blind. And a question that I often get asked about double blind studies is, if the subjects don't know who's in which group, and if the evaluators don't know, then Who knows? And this is why randomized controlled experiments can be complicated. They're ideal, but there are some cons. They can be difficult to do because you would actually have to have a third party or a third person that knows who's in each group that can essentially reveal that at the end or when they're ready for analysis. So that's just a common question that I've heard, which kind of explains why these can be very complicated. And then the very last part of this question says, what can we conclude and why? And this is the key because we did that ideal experimental design, we can conclude that there is evidence. I'm going to go ahead and say that there is evidence that what we saw is true. So that the GB improves those two measures, cognitive performance and social functioning, for 6 months to 1 year. At least that was the length of this study. Maybe it could be longer, but we don't know. This study was 6 months through 1 year. So there's evidence that the GB improves cognitive performance and social functioning of the patients for 6 months to 1 year. These questions were kind of a good idea to get you used to reading a study, picking out the important parts, and then even more importantly, figuring out, okay, what does this mean to me? So let's do one more puzzle. This is puzzle number 2. It says a statistical study was done to test the effectiveness of a new diet pill this year at Carle Hospital. And the researchers wanted to determine if the diet pill worked to help patients lose weight after 6 months. So again, we have an example of a pill that's super common for these randomized controlled experiments. And this says they recruited volunteers for the study and decided to give all of them the diet pill. So I might have spoke too soon. This probably isn't a randomized controlled experiment because they're not randomly dividing the subjects. It says they wanted to compare their weight loss percentage to the patients from last year who didn't take the diet pill. So the first question asks us, is this the ideal experimental design? So we have to ask ourselves, were those 3 characteristics present? Was this randomized? Was it controlled? And was it double blind? And we said it definitely wasn't randomized. They didn't mention that. It looks like it wasn't double blind either. They know they were comparing the patients who took the pill to patients from last year. And then it technically was controlled because we do have that comparison group. But this isn't ideal. In order for it to be ideal, you'll have to meet all 3 of those criteria, not just one. So I'm going to go ahead and say no. It says, if so, why or why not? So I'm going to say no. The worst part of this study is it's not random. So no, because the study is not random. And specifically in this study, we're comparing the subjects who get the treatment to subjects from the past who didn't get the treatment. And this is actually called a study with historical controls, historical being a control group in the past. And historical controls aren't ideal because past and present conditions can be different. So I could even include here for the why not. I'm going to also add past and present conditions are different, and that could affect the response. If we're trying to, again, always think of our main goal, we want our treatment and control groups to be as alike as possible. Patients this year and patients last year aren't going to be as alike as possible. So the second question asks, how would you design this experiment if you were able to choose? And here, I feel like this is a short answer. We would just use our experimental design, right? Our ideal experimental design, the randomized controlled double-blind experiment. So instead of using the controls from the past, I would take all of my participants, randomly divide them into a treatment and control group, and make sure that the treatment group gets the treatment, the control group gets a placebo, and that the evaluators are also blind to that knowledge of who's in each group. So this is an example of a study that is not ideal, but could be made into ideal with a few adjustments. So to answer this question, I'm just going to say that we would use our ideal design, the randomized controlled double-blind experiment.